Hi guys, welcome back to my channel Pirai Academy. In the series of data structure playlist, today we are going to see about logical implementation of doubly linked list. Okay, so before getting into this, if you already saw the singly linked list video, implementation video, just go and try this doubly linked list implementation by yourself. You already know the structure of the doubly linked list, right? So you can try these all functionalities because the ADT are like insertion and deletion same as the singly linked list. Whoever already saw my video for the singly linked list, again go and try this doubly linked list by yourself, so that you can make some mistakes there and you can rectify those mistakes again when I am showing you the code implementation of this doubly linked list. The code implementation of the doubly linked list will be in the next video. Now it is entirely going to be the logic. Once you have done this video, then you can go and write some code on the doubly linked list. Okay, let's get started. So as you already know, the ADTs of the doubly linked list, for any linked list, it will be like insertion and deletion, and for both, it will be beginning, ending, and at the particular index they have given. Okay, fine. So before this, I want you to understand some of the recaps from the previous video of the linked list, where I have clearly told how the structure of the doubly linked list is going to be. So a recap. See here, the structure of the doubly linked list is going to be like, there will be three parts. One is data, another one is the previous address, another one is the next address. So previous address is going to be stored the front node address, and the next address will be going to store the next node address. Can you understand this? Okay. So the basic fundamental structure of the linked list is going to be like, for example, if this is a one node of value something like 5, and here is another node of value something like 10, okay, and its next going to be null and its previous is going to be null, and take for example its address is 200, then here comes the 200, and for example its address is 1000, then here comes the 1000. Can you understand this? So that there will be a linkage between them, like from here to here and here to here. Can you understand this? Yes. So this collectionally called as doubly linked list, because see here it has three parts and this node also has three parts, right? So this is going to be the doubly linked list. And also I want you to understand two terminologies new. One is head, as you already saw this head in the singly linked list itself, but there will be one new thing called tail. Tail means the last node, head means the first node. That's it. Okay, now this is enough for getting into the logical implementation. Okay, fine. So let's get started quickly. See here, first of all, before getting into this, initially we will be having our head and tail. These both will be equal to null initially, which means our linked list, the doubly linked list, is empty initially during the implementation. Okay, at the beginning stage. Okay, what is the first functionality I am going to do? Insert at ending. Insert at ending. Okay, first of all, I want to check whether my linked list is empty. Whether my linked list is empty here. Yes, yes, because head and tail are both pointing to what? Null. So at this particular point, what should I do? I will be just creating a doubly linked list node there itself. Okay, just create a doubly linked list node. So this is going to be a doubly linked list node. And what is going to be the data? Data going to be 4, and it should be having some previous address. So as of now, the previous address is null and its next address is also null. So this is going to be the new node where the head and tail both will be pointing to this new node, as there is nothing left. Now only there is only one node, right? So head and tail will be pointing to that node. Can I understand this? Yes. Okay. What is the second functionality? Insert at beginning. What is mean insert at beginning? Some node called 5 should be coming here in front of it, and head should be pointing here, tail should be pointing at the this place itself. Can I understand this? Okay, let's do this so that you can understand. So let me take any other class. Okay, now I'll be creating a new node called 5, and its previous address is going to be null, And what should be its next address? Next address should be pointing to the head value. To the head value. Because see here, when I am going in the beginning, insertion at the beginning, I want to create a new node, and its next should be pointing towards the head, and head should be replaced again to the new node. Can you understand this? So which means, for example, its address is going to be like something like 200. Then I'll be changing here as 200, and make this head to point here, okay. And for example, say this address is 1000. Then make this null into 1000, which means there will be a link like this and this. Can you understand this? Yes. Okay. Now again, what we are going to do, we are going to be inserting at the end of 12, which means whenever there is a insertion, except the insertion at the index. Okay. Whether we can insert any element in the beginning, yes. Whether we can insert any element in the ending, yes. But if there is insertion at the index, but the index is not found, or the index is out of range, then there will be some exception. Rather than that, we can anywhere we can insert it, right? So first of all, I will be creating a node here. That's the reason why I am creating a node here. Okay, and here what should I do? 12. So put 12 here, and its next address will be null. What should be its previous address? Just think. What should be its previous address? The previous address should be the tail. Can you understand this? Okay, so what is the tail address? It is 200. So just write here as 200, so that a linkage will be like this. Yes. Now go to the tail pointer value, and change that next address to the this newly created node address. For example, the newly created node address, let's take as 500. Okay, then I'll be going to the tail pointer here and change this null into 500, so that like this a linkage will be created. Oh, if I just made this y pointer to come here, it will be looks like some Indian flag color. Okay, fine. So this is what the link list has of now. Now what should I do? I should be changing this tail to come here. Can you understand this? Yes. So that now it is like 5, 4, 12. Correct. Yes. Now what is the next thing? Next thing is insert at a particular index of, see here, index 2, and you want to insert 32, which means it is index 0, it is index 1, it is index 2, which means my result should be like 5, 4, then comes 32, then comes 2. My result should be like something like this. But as of now, we are having 5, 4, and 12. Okay. Now, sorry, what I told last time? 2, right? Sorry, here comes 12. It's 12. Sorry. Okay. So my result should be like this. Fine. Okay. Now what should I do? I will be just taking a temp value from the head. Similarly, like the singly linked list. Okay. Now I want to move one step forward. Because what is the index? Index is 2, right? Index is 2, which means I want to go to the first index node, and I'll be inserting a node after to the first index. Okay, just concentrate here. It is somewhat important. Okay, see here, I will be moving one step forward. First of all, I want to check whether it has next. Yes, 200. It has next, right? As 200 address. Okay, then take my temp value and move to the 200. So it comes here. Okay, one step is over. So whether how many steps you want to go? We want to go for only one step because the index is 2, right? So we want to go for only one step. Okay, I came here. Now what should I do? I will be creating a new node because see here we have next address. Right? So I want to create a new node. So I will be creating a new node, and this node will be of 32. Okay, and its next will be pointing to temp's next address. What is temp's next address? It is 500, right? So it will be pointing towards 500. Okay, what should be its previous address? What is the temp's address? It is 200. So it will be pointing towards the 200, the previous, which means from here there will be a linkage, and from here there will be a linkage. Now in the next step, what should I do? I will be making this 200 to the address of the newly inserted node. So what is the node address? For example, the node address is 400. Then here comes 400, which means instead of this linkage, I will be having a linkage like this. Okay. Similarly, here also, instead of this 500, I will make this as 400, which means temp's next will be equal to the new node, so that this linkage will be formed here. Now we have successfully inserted the new node at the particular index. Can I understand this? Okay, let's move on to the next thing. Next thing is going to be very important. Insert at index 5 of value 10. Okay, so what is the procedure for this? I will be taking this as temp. Initially I will be taking this as temp. Okay, here is 5, which means I want to go for 4 steps. Okay, go. So at the first step I want to go for the 200. Okay, here is my temp. So first step is over. At my second step, where should I go? I should be go for the 400. Okay, go. So my temp will be now here. At my third step, where should I go? I should be going for the 500. Okay, go. At my fourth step, where should I go? Null. There is nothing left. Which means I haven't completed 4 steps. I haven't completed still 4 steps. So it is basically defining like, hey, you only have index up to 3, but you are telling me to insert at the index number 5. To insert at the index 5, you should be having index called 4. But here there is nothing like index called 4. So I cannot insert it. It is out of range. The index is out of range. That's it. Can you understand this? So this is the important edge case. This is going to be your exception. Can you understand this? Okay, let me clear this out and let us continue with this deletion. Okay, wait a minute. So here it is a delete at index, some index called 2, right? So initially here is my head and here is my tail. I redraw that doubly linked list in the Indian flag. Okay, fine. So see here, delete at index number 2, which means it is 0th index, it is first index, it is second index, and it is third index, which means I want to delete the second index. Okay, to delete the second index, what is my goal? I will be pointing this linkage to here and its previous linkage to here. That's it. Then I want to free this space. Can you understand this? So this is going to be my process. I want to go to the first index. And make the linkage to its next, which means I want to make a linkage to here. And for the third index, okay, I want to make its previous as my previous. Can you understand this? So this is going to be done in this process. Okay, let's get started. So initially I will be having my temp here at my head. Okay, now how many steps should I go? Here the index is what? 2, which means I want to go for only 1 step. Okay, make my temp to move 1 step. Okay, now what should I do? I will be making a temporary pointer called something like t, whatsoever you can take. Okay, instead of t I can take this as d, node to be deleted. Okay, as the temp's next node. See here, there is existence of temp's next node. It is 400. Right, the address is 400, which is this node's address. Can you understand this? Yes. So I want to go to that node and represent that node as some pointer called node to be deleted, like that. Okay, now the next step is going to be like, I will be making the temp's next to its next, which means I will be changing this 400 into 500, which means I will be having a linkage between them. Okay, and my temps next address, now this is this node, its previous should be its previous, which means this will be changed into 200, which means I'll be having a linkage between like this. Yes, and then I will delete, or I will be freeing the space of this particular pointer. So this will be deleted. This will be deleted. Finished. Can I understand this? Yes. So rather than this, there is nothing. There is nothing. Okay. Now, what is the next? It is delete at beginning. Delete at beginning. So delete at beginning is so simple. Okay. So what we are going to do is, I'll be making my head pointer as temp. My head pointer as temp. Okay. Now I'll be moving my head pointer to head next. Head next. So that it will be something like here. Okay. And making its previous to point to null. To point to null. So that this linkage will be deleted. Now I'll be delete or free the space of this temp. That's it. Can you understand this? Yes. So this is going to be the delete at beginning. Now delete at ending. How we are going to delete at ending? So it is also so simple. Go to the tail pointer. Go to the tail pointer and make the tail pointer to move one step forward, which means tail is equal to tail's previous. Tail is equal to tail's previous. What is tail's previous? It is the head here, because this node is deleted, right? This node is deleted in the previous steps itself. So this is going to be your tail. This is going to be your tail. Can you understand this? Yes. Now what is the next step? I will be making my tails next to null. To null. And before changing this tail to come here, I will be making this as something called as node to be deleted. And after making this tail to shift here, I will be deleting this node to be deleted. Now I am having only one node called 4, and here has none, here has none, and tail is also pointing here, and head is also pointing here. Can you understand this? Yes. Now again, delete at some index called 3. Some index called 3. So listen this carefully. This carefully. So see here, this is going to be your temp, right? This is going to be a temp, and whether I want to move how many steps? I want to move 2 steps, because the index is 3. The index is 3, which means I want to move 2 steps. Whether I can move even 1 step, because the temps next is what? None, which means I cannot move. I cannot move. So at this particular point, what should I do? I should be giving like, hey, index is out of range. That's it. Because we want to move 2 steps, but I can't even move 1 step because of this none. Can you understand this? Yes. Okay. Now delete at end. Delete at end means what? What should we do? We will be making my tail pointer to move tail's previous. Tail's previous. But here the tail's previous is what? None. Which demonstrate that there is only one node left. It demonstrates what? Only one node left. At this particular point, what should we do is, we will be making our head is equal to null, and also tail is equal to null after deleting the tail node. That's it. So what it represents? There is nothing left in this doubly linked list. Again, I am doing a delete at beginning. So see here, the head and the tail is equal to null, which means there is nothing left. So here also I will be telling like, hey, the index is out of, sorry, that we cannot delete. Can you understand this? So this is the whole implementation of the doubly linked list. After watching this video, now you want to take your coding implementation by yourself first. Okay, and then after trying n number of tries, come and watch my code implementation, because I want you to try so that you can understand your mistakes. Okay. Now let's see about the time complexity. In the singly linked list, I forgot to mention the time complexity. Okay, that's the reason why I have given the text format. Okay, here let's see the time complexity. So tell me, what is the time complexity of at the beginning? So let me write where. So here is a file you can write. Okay, at the beginning, what is the time complexity? It is O of 1, because we will be just inserting a new node and its new node next will be pointing to the head, and head previous will be pointing to the new node, and head will be now pointed to the new node. Okay, end is also O of 1 because of the tail pointer, because of the use of the tail pointer. Whereas in singly linked list it will be O of n because we want to traverse up to the n elements, right? Okay, what is the index? It is going to be O of n depending on the index. At the worst condition it will be O of n because they will be giving nth value. Okay, now at the beginning here also it will be O of 1, and here also O of 1, and here it will be O of n. So this is going to be your overall time complexity, and telling about the space complexity, it will be O of n, the number of nodes they have given. That's it. So this is the whole time and space complexity analysis for the implementation of the doubly linked list. In next video, we shall see about the code implementation of the doubly linked list. If you really like this video and subscribe to my channel, don't skip any videos in this playlist because all videos will be helpful once you are going in the problem solving session. And if you have any doubts regarding this video, you can just comment below. I'll be commenting out answer, or I'll be giving you the separate video on it. Thank you.